Hello everybody, this is the second video clip for the first chapter. For this video clip, we are going to learn more about the limit of a function, okay? So for example, if you are given a function f of x equals to x minus x squared over the absolute value of x, do you still remember that the absolute value of x take two kind of value? It can be x if your x is greater than or equals to 0. It can be negative x if your x is less than 0, okay? So this is the absolute value function. And actually, as you can see pretty clearly here, that if your function containing the fraction like this, okay, so it means that the bottom of this fraction cannot be 0. So this means that this function, okay, cannot evaluate a value whenever your x is 0, okay. So this function, the domain of this function, actually it is the order real number except that point 0. However, we still would like to know what is the behavior. Can we find the behavior of a function f, okay, as your x like go close to 0, okay? So on the number line, the 0 is right there. So to go close to 0, you can go from the right, okay, which is this picture, right? If your x here, okay, this is x is greater than 0, okay, so it is on this table, okay. You can start from, for example, 0.5, okay, is that close? So you can find the value of f of x. You can use your calculator, okay, to be like 0.5 as well. And then if you get closer a little bit, 0.3, so you got 0.7. Go a bit closer, 0.1, you got 0.9. If you go closer, 0.01, you have 0.99. 0.001, you have 0.999. If you go more close, 0.0001, you have 0.9999. So can you make a guess? If you have 0.00000001, what is your function value? Okay, so it will take 0.999999, okay, corresponding to the x value that you put in, that you plug in, right? So this one is like if you plug in your x that is positive, so it means that you go from the right of that number, okay. However, you can start from here, okay, which is your x here is negative, right? Okay, and then you just go close, okay, but don't forget that this one will never goes to 0, because you cannot evaluate, you cannot really evaluate your function at 0, right? So this one just getting closer and closer. So here, if you start from the negative, you can start from negative 0.5, you got negative 1.5, negative 0.3, you have negative 1.3, negative 0.1, you have negative 1.1, okay, negative 0.01, getting closer, right? Negative 1.01, negative 0.001, you have negative 1 with 0.001, okay, and then here, if you have 0.0001, you got negative 1.0001 as well. So if you go to negative 0.0001, okay, can you make a guess how many decimal places, okay, of 0 that you go and then you reach 1? You can see some kind of relation like that, right? Okay, so actually, as you can see, okay, this one again go really close to 0, okay, but it never be 0, it just go close, okay. What is the behavior? Actually, you can make a guess of the behavior of this function, that it will go close to what? It will go close to 1, okay. Okay, if you go from the right hand side of the 0, but if you go from the left hand side of the 0, this function value will go close to what? Will go close to negative 1. Okay, will go close to negative 1. So I mean, how can we, I mean, if you keep doing it like this with several functions, that will be pretty difficult because sometimes, I mean, you really need a calculator, right, in order to get this kind of numbers. Okay, do we have some other method that may be like easier? Okay, so before we look at that, okay, let us introduce some of the notation first. Okay, so we can see from the table that if your x approaches 0 from the left, okay, which is whenever your x less than 0, the value of your function f of x approaches 1. Okay, sorry, -1. We say that -1 is the so-called left-hand limit of your f of x as your x approaches 0, and it is denoted by this equation. Okay, this equation, and please look at it carefully that to indicate the left hand side, we indicate it by the superscript negative. Okay, so it is x goes to 0, and we read it as x goes to 0 from the left. Okay, so this one is like 0 and then superscript by negative here, okay, of the limit of this function as your x approaches 0 from the left equals to -1. So keep in mind that your function value can never be -1. Okay, but it just go close to. Okay, so this word limit just saying that a function value go close to -1 as your x go close to 0 from the left. Okay, on the other hand, if your x approaches 0 from the right, okay, which is where your x greater than 0, you can see from the table again that the value of your f of x approaches 1. So this one we saying that um, this is the typo. We say that 1 is the right hand limit of a function f as your x approaches 0, and we are going to write it as limit f of x go close to 0 and then positive. So again, this one is like a superscript positive. Okay, this one equals to 1. Okay, and it is read as limit of a function f of x as your x goes to 0 from the right, okay, equals to 1. Again, your function value can never reach 1, okay, but it just go close to 1 as your x go close to 0 from the right. Okay, so this notation and this notation just indicate, okay, the direction of your x approach at that point. So for example, if you say x go close to 1 and then put a negative as a superscript there, so it means that your 1 is right here and your x go from the left hand side of that number. So it's not related to -1 at all. Okay, so please keep this in mind. So this one is not the sign of a number, it's a symbol saying that it is approaching from the left or from the right. Are we get? So we can have x to -2 and then plus there. So it means that -2 is here, and then your x approaches from the right hand side of -2. Are we get? Okay. So as we told you that it will be difficult if you keep uh, having that table. Okay, so how are we going to make our life easier? So let us do it like this. Okay, as I we remind you again that the absolute value of x equals to x if your x greater than or equals to 0, and equals to -x if your x is negative, right? So but however, your absolute value of x right now, it is at the bottom. So your x cannot be 0, okay? So the cases will separate as your x is negative, okay? The absolute value has a negative x there. And then if your x is positive, okay, if your x is positive, then the absolute value is a positive x, it just equals to itself there, okay. And then because right here your x is not 0, your x is also any number that is not a 0, so it means that your x actually can cancel, right? Because you have a common factor x on top, both of them. So actually this one is x 1 minus x, okay, on top, and then over the x at the over the negative x at the bottom, right? And because your x is not 0, so here and there we can cancel, and then this negative will distribute it in. So you have -1 plus x if your x is negative. And for this one, same thing, okay, you are going to have what, x, and then x 1 minus x, okay, 1 minus x over x, and then your x is not 0, so it means that you can cancel that, and then here is the function value as your x positive, okay. So can we draw a graph of this kind of function? Actually we can do it very easy, right? Because both of them have a x of a power 1, so it is a straight line, okay. So by a straight line you just need only 2 points, okay, to get the straight line, okay. So one of them is that, like, if your x is 0, okay, even though we say if your x is 0, okay, because it is a straight line and then you cannot see 0 here, but we just pretend that it is there first, and then later on we are going to get rid of it, okay. So here if your x is 0, your y is -1, so it's cutting your y here, okay. And then if your y is 0, okay, so if it equals to 0, your x is actually what, your x is actually 1, right? So it will cut your x axis here, okay, for this first straight line. So you have that straight line, right? However, this straight line valid whenever your x is negative. So right here is 0, and there is when your x is negative, right? So this means that this one cannot be used, okay, the whole line, okay, and also your x at 0 cannot take place there. So the way we draw this straight line here, okay, we are going to get rid of the one that it is go beyond the negative, okay. And then also to indicate that the 0 cannot take place here, okay. So let me just do it pretty neat, okay. So here we are going to use the white dot, okay, to indicate that the function value is not take place when your x is 0, okay. On the same token, if your x is 0 here, your y is 1, and if this one equals to 0, your x is also 1. So actually it is cut, the line that's cut here. However, you cannot use the whole straight line because this one valid whenever your x is positive. So right here is your x is positive, right? So you are going to use only this part of the graph, okay. So here we have 1 here, okay, and then it is cut there, and then we again using the white dot to indicate that we are not going to include that particular function value, okay. So actually we have a nice looking graph right here of this function f of x, okay. So we can see that at 0, okay, we have like 2 pieces of the graph tearing apart, and this one sometimes we call a jump, okay, we call a jump. And if we have a jump like this and the graph becomes like more than 1 piece, okay, here we got 2 pieces, right? So we say that your f is not continuous, okay, is not continuous. And in particular, this one is not continuous at x equals to that particular point 0, okay. And how are we going to find the limit if we are given this kind of graph of a function? It's not that difficult, right? Saying that if your x if we want to find the limit as your x goes to 0 from the right of this function, so it means that we start our consideration here, okay, or we can start from here, okay, just anywhere that really close to 0, okay. So here we have a function value of 1, and then if you're getting closer, a function value is getting larger and larger and larger, right? But the function value keep approaches what? Approaches 1, okay? So this one from the picture, we say that this limit equals to 1. And we see from here that this one again is undefined, okay? It's undefined. On the other hand, if you want to find a limit as your x goes to 0 from the left of a function, of this function, then we start from somewhere here, okay? So, and you look at a function value, okay, it take this place, and then as your x getting closer, okay, it is increasing, right? It is keeping going up, and then it approaches what? This number. So this one from the picture, it goes to -1. Again, this one, your f at 0 are undefined. Okay, this undefined there. Are we all right? Okay, so here is like, if you having a picture, then you can find a limit. Okay. And how about like somewhere else? Okay, let's look at the graph again. Okay, let us look at the graph again. If we considering this point, and if we want to find a limit as your x goes to goes to 1 from the left of a function, okay, so here we start from here, right, like close to 1, but it is like on the left hand side. So your function value take place here, and then it will smaller, smaller. So your function value go close to what? Go close to 0. Okay. On the other hand, if you look at your x goes to 1 from the right, okay, from the right. Here is from the right, okay. Your function take place there, and then it getting bigger, 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 okay, but it approaches what? It approaches 0. So this one is also equals to 0, okay. So if this kind of thing happen, so it means that the limit either go from the left or go to the right, they are the same. So we are going to say that the limit as your x goes to 1 of your f of x, either way, you see, either way will equals to what? Will equals to 0, okay, will equals to 0, okay. And we can see also that f at 1, if your x is 1, okay, so right here you have 1 minus 1 square over the absolute value of 1, which is 0, right? So f at 1 is 0, and it is the same as that limit value, okay, sorry, that limit value, okay. And we can see from the graph again that at this point, okay, there has no jump, okay, the graph is not tearing apart at this point. So we are going to say that at this point your function f is continuous, okay. So this one, your f is continuous at x equals to 1. We okay? So let's go to the next example. Okay, for this example, your g of x again depends on a fraction. So this one, it means that your bottom cannot be 0. So it means that your x cannot be -2. However, we are going to like to find what's the behavior, okay, of this function. So actually, as your x go close to -2, so actually this one on your top can be factorization like that, right? Because it is the different square. So this one is x plus 2. And then because you say that your x is not -2, so this one, it means that it will never be 0. this one will never be 0. So you can cancel, right? So it means that actually your g of x, it is x minus 2, but your x is not -2. So again, here is a straight line, okay? Okay. So if your x is 0, your y is your y is -2. And if your y is 0, your x is 2. So it is a straight line like that. However, it is saying that your x cannot take place whenever, a function value cannot take place when your f equals to -2. So it means that at -2, this one must be a white dot. Okay, this one must be a white dot. Okay, so let us getting the graph a little bit above here. Okay, so x is 0, so right here and there. Okay, so we have this graph just like that, 2 and -2, right? Okay, and then as your x goes to -2, it will be a white dot, and then it will be continue as the same line. Only at this place, okay, at this point, that your function cannot evaluate the value. Okay, so at this point, okay, at this point, actually your graph got two pieces. Okay, so this is one of the pieces, this is another one of the pieces. Okay, it is tearing apart at that white dot. Okay, however, at this white dot, if you just forget about it, okay, if you just forget about that white dot, can we evaluate this one? Can we evaluate the value? So actually it is the value of that straight line, right? Of this straight line. When your x equals to what? -2. So it will be -4. Okay. So it means that if you are going to let yourself approach -2 from the right, okay. So for example, if you start here, this is a function value, and then the function value like getting smaller, smaller, and smaller, but it is approach what? -4. Okay. If your x go from -2, go to -2 from the left, okay. So here's a function value, and then there, okay, getting bigger, bigger, but then it approach what? -4. So it means that actually from that curve, okay, from that graph, the limit as your x goes to -2, either from the left or from the right of this function will be equals to -4. So what can you conclude? Okay, so it means that this one, okay, equals to -4. However, still your g at -2 is undefined. Okay, and still your graph tearing apart at this point. So it means that your g still is not continuous, okay, at the point x equals to -2. Okay, at the point x equals to -2. We get? Okay. So here is like the graph, okay, and then the limit that we just talking about, and also the conclusion about the continuity, that your g is actually not continuous at x equals to -2. Why don't you do it by yourself? Okay, whether we can find a limit as your x goes to 0 from the left, and a limit as your x goes to 0 from the right, and also the limit as your x goes to 0 of your gx, and whether your g is continuous at the point x equals to 0 or not. Okay, so let you do this one by yourself a little bit, okay, because you are already having the graph gx right here. Okay, so let's say in general, okay, the limit as your x go to a, and then having this negative as a superscript here, okay, equals to L, it means that the left hand limit of a function f of x as your x approaches a equals to L. Okay, and on the other hand, if this one is positive, then it means that your L is the right hand limit of a function f as your x approaches a. Okay, and without any sign indicated, it means that your L is the limit or the two-sided limit of a function f as your x approaches a. Okay, so it means that if this one equals to L, okay, if this one equals to L, then it really means that the left hand side and the right hand side will equals to the same number, okay, to the same number L, like that. Okay, and as we say, I mean, as we saying a number, then it means that we are talking about a real number. Okay, and another definition is saying that if your f is continuous at x equals to a, so it means that your f at a must be defined. Okay, so it means that you are not going to have this y dot at a. Okay, okay, and then a limit as your x goes to a of this function exists. Okay, exists. All right, so it means that your graph is not like tearing apart like that. Okay, and then these two things must be the same. Okay, the limit of a function f of x as your x goes to a and a function value f at a must be the same, so that it will patch the 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 hole here, and then you see your curve or your graph as a one piece curve over that point. Okay, so here is a graph of a graph of a functions and a continuity. Okay, so let's look at this one. This one we saying that our f of x, okay, it is continuous at your x equals to a, because the graph like having one piece, okay, over that point. All right, and then actually we from here, because this a function value at this point is L, so actually it means that the limit, okay, as your x goes to a of this function equals to L as well. Okay, and they are the same, they are the same. Okay, how about this one? This one, the limit, okay, because the limit, it has nothing to do with a function value, right? We just look at the value that's closer. Okay, so if you look at the a here, as you go close to a from your left, okay, so the function value approaches L. As you go close to a from the right, a function value also approaches L. So it means that the left hand side and the right hand side limit, they are the same, they're equals to L. So the limit exists. Okay, the limit as your x goes to a of this function exists and it equals to L. But a function f at a, okay, equals to m, which is not equals to L. Okay, so this means that at this point, the function tearing apart into two pieces. This is one of the piece. Actually, this is two pieces, and this is the third piece. Okay, so here your f is not continuous. Okay, at this particular point. Okay, at this particular point. How about this one? Okay, this one again. I mean, from the left, you can find that your function value going close to L. From the right, okay, also your function value going close to L. So it means that the left hand side and the right hand side limit, they are the same, L. And the limit as your x goes to a of this function exists and it is equals to L. However, this one is a white dot, so it means that your fa is undefined. So here, if you got like this, so it means that at this particular point, you got two pieces of the curve, okay? One piece here, one piece there. So it means that your f is not continuous at the point x equals to a under consideration. Okay. The third one, okay, you see pretty clear that you have one piece here, one piece there, and this one here. So actually we can say immediately that your f is what? Is not again continuous at the point x equals to a. What can we say about the limit? Okay, we can say that, hey, if you go close to a from the left, okay, for example here, okay, your function value approaches this capital A, right? So here, left hand side limit exists, it is equals to a. How about the right hand side? Okay, so from here it is going up, right? It is bigger and bigger. However, it will approaches this b, so it means that the limit as your x goes to a from the right equals to that capital B. However, the a and the b, they are not the same, so it means that this limit, okay, as your x approaches a without any indication of the direction, does not exist. Okay, does not exist. However, how about f at a? F at a right here equals to m. Okay, you got a function value. Okay, but still, this one you can see immediately from the graph that it cannot be continuous, right? Okay, and this one, okay, this is another tearing apart, but your function value, okay, your f at a either way is undefined, right? So same thing, the limit as your x goes to a from the left, okay, from the left, so from here, right? So it will approaches what? Approaches b. But from the right, okay, so it approaches a, right? But they are not the same again, okay, as a limit from the left and from the right are not the same. So it means that the limit of this function as your x goes to a does not exist, cannot determine, right? And also f at a is undefined, and you can see immediately that here you have two pieces of the curve, so your f is also not continuous, okay, at x equals to a, okay, for this curve. So let us look at this function and then try to find some of the value here, okay? So you can see that here is like one piece of the curve, two piece, three, and then four, right? Right. So it means that at each and every point here on the curve, okay, we don't have the point that the curve is tearing apart, okay? So from here to there, the function is what? Is continuous. From here to there is also continuous. From here to there is continuous. From here to there is continuous. However, at some places that your function really tearing apart. For example, at this point, okay, you see x equals to 0, x equals to 1, x equals to 2, okay? All these places, okay, your function is not continuous, okay? So it means that your function is continuous at every point except x equals to 0, x equals to 1, and also x equals to 2. Can you find a function value, okay, when your f is 0? So here is 0, and then you just go up to, I mean, either go up or go down to your function, okay? But this one, your curve is up there. So the function value at 0 is 1, right? How about at 1? At 1 here, you go either up or down to find the curve, okay, the graph of the function. So this one is not, because it is a white dot, so you need to go further to meet there. So if your x is 1, your function value is 2. How about your f at 2 right here, okay? So this one you already hit the graph, okay? Actually, this was one of the graph as well, not this one, okay? Because here is the white dot, okay? So here's a function value when your x is 2, which is what? Which is 1, okay? How about the limit, okay? Can you determine the limit? This one, the first one, you are considering when your x is 0, okay? if you are going to 0 from the left, okay, so here it will go bigger and bigger and bigger, and it approaches what? 2. Okay, so here's 2. If you if you go to 0 from the right, okay, so here from the right, so it steady, right? Okay, always 1. See, always take a value 1. So this is 1. So what does this mean? This one does not exist. Okay, and sometime or some book they will abbreviate by DNE. Okay, does not exist. Okay, so sometimes we are going to abbreviate like that as well. So as your x goes to 1, okay, so here is the second place here. Okay, so you see again from the left, it keeping what? Steady, right? Always the same, and the same point is what? Take a value 1. If you from the right, is also steady, you see? Okay, steady. They are the same value 2. Okay, and this 1 and 2, they are not the same. So it means that limit as your x goes to 1 of this function does not exist. How about at 2? Okay, at 2, here. Okay, so at 2 from the left, it is a function value is steady again. Okay, always equals to 2. So here's 2. And then from the right, okay, it starts from here and then it goes up, right? It goes up. But it go close to what? To 2 as well. And they are the same. So it means that this limit as your x goes to 2 of this function equals to 2. Okay, so this is like if you are given the graph of a function, then you will be able to determine a function value, the limit of a function at each and every point, okay, and also to see whether the limit at each and every point exists or not. Okay, all right, so we are going to stop this video clip right here, and then we will continue like what if we cannot see the curve, we cannot see the graph of a function, then what are we going to do? Okay, or if it is like so difficult to graph the function, how are we going to define, or how are we going to determine the limit of a function at a particular point? Okay, so we'll see you on the next video clip. Bye bye.